Our next speaker, Greg Leslie, who's going to come up and do a demonstration, is a Deputy Director of the UNESCO Centre for Membrane and Science Technology at University of New South Wales. So that makes us natural enemies, just for a start. And as if it couldn't be worse, when I came up to him and I said, Greg, tell me something about yourself, he's whipped out a key ring, and on the key ring is a 2014 Rabbitohs pin. So he's also a mad, or rabid, should we say, Rabbitohs supporter. So that's two things that are problems between us. Nevertheless, he is going to come up now with a couple of students called Amos and Lloyd. And they explained in detail to me what they're going to do. It was something about water purification, blah, 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 blah. The key bit that I latched onto was they're going to extract alcohol from water. And I noticed at this point a whole lot of you sat up a little bit straighter and said, I'm going to watch this shit. Definitely worth it. Please welcome Greg up. He's our next speaker.
Thank you, Chris. Oops, come on. Okay. A pleasure to be here. It's a great space. It was a fantastic welcome to country. It's a great talk, a great topic. I'm an optimist. South Sydney won after 43 years. For me, the glass is always half full. What I want to talk about tonight, and I'm here with two of our very bright students who are doing their PhDs, Amos and Lloyd. They're going to give us a demonstration of a technology that underpins a lot of the systems that we've heard talk about tonight. Small-scale urban recycling at Green Park. The wonderful systems that Sydney Water have that recycle wastewater from Penrith and St Mary's, put it back into the Nepean River so that we can conserve water behind Warragamba Dam. So they recycle wastewater for environmental flows. And of course the desalination plants that have helped out not only cities like Sydney, but also Perth, Adelaide, Melbourne, the Gold Coast, as well as cities all around the world that are struggling with the problems of water supply. We have moved from an era where water was used to generate electricity to one where we need electricity to generate water. At the heart of it is a reverse osmosis membrane. One of many styles of membranes that all use pressure to push water across the membranes and take out contaminants. Lloyd and Amos will demonstrate how to take the ingredients of gin and tonic out of water. We've chosen to do that because it's a good visual. What you're looking at the moment is the quinine in a gin and tonic. And again, you'd say, why are you doing this? Is the quinine, it fluoresces under UV light. It passes through a reverse osmosis membrane. It's a very small molecule. And the product water will come out in the other tap there. And when they turn that light on, you'll see that it's clear. It's a really useful technology for removing contaminants, be they organic molecules, salt molecules, from water. We have it because in the 1950s, the US government decided to invest in two publicly funded science programs. One was NASA, or the precursor to NASA, and the other one that got just as much money was the Office of Saline Water. And there was an acknowledgement at that time that growing populations were going to need to be underpinned by reliable supplies of water. And they set in train multiple phases or tranches of investments that gave us the reverse osmosis membrane. If you have a look at some photos, these plants, this is one from a facility in Spain, exist pretty much in every city around the world for one use or another. They're used in industries. They give us the ability that previous generations didn't have. The Romans needed to transport water to cities. Early civilizations found places where there's fresh water and developed their cities around there. This technology allows us, as it's seen in the space station or in Green Square, to find water where we have it, of any quality, salty, dirty, and turn it into what we need. The challenge that we've got is, and here's an example of the incredible growth in Australia. Australia had, about 8 years ago, 45 gigalitres of reverse osmosis capacity. we're now over 500 gigalitres. It comes at an energy cost. We've had to install systems that provide or use around about 260 megawatts of power, about the size of a good-sized power station to run that. But the point that I'd like to make is if we think about how we use water, we will see that even though that might sound like a big number, there's ways to offset it. And the simplest way to do that is by looking at alternative sources of water that don't have as much contaminants in it, and stormwater is a classic example. Keir was absolutely right. We need to do water-sensitive urban design a lot better. Capture the water that is available, lightly contaminated, and reuse it for the appropriate applications. And so here's an example of a facility that we have at the university. That's those of you that know the University of New South Wales, that's the Village Green. And about 10 years ago, when we got a good rain event, the oval would flood. They've since ripped up about a third of it and buried things that in good student fashion look like milk crates, which most people would convert into put a mattress over and make into student bedding. But the milk crates are actually structural elements. You put the dirt back over on top of it. It's wrapped in a fabric, which is also like a membrane. And the stormwater collects in there, filters down into an infiltration gallery, and is used around the campus for irrigation. So from desalting through to stormwater harvesting, we can find the water that we need. But the last point that I want to just dwell on is where the real savings, though, are in how we use water. Now, one of the things that happened with, I think John Key was the one who initiated it, was to bring in legislation to phase out the incandescent bulbs, because fluorescent bulbs and LED bulbs are up to 5 times more energy efficient, okay? What we also need to think about, and that's for lighting, we also need to think about how we use water. And that number that I showed you before, the 260 megawatts of power that's being used by our desal plants around the city, around the country, we can offset that by increasing water recycling, by stormwater capturing. But the easiest way to offset the power that drives all of those desal plants is not necessarily through wind farms, although that's good. It's by going to every 100 houses that has an electric hot water heater. And in those 100 houses, just replacing it with a solar-powered hot water system in 3 of them. So if 100 houses in Australia, or sorry, every 100 house in Australia, if we could just drop out 3% of our current electric hot water heaters, we would offset all the energy associated with our desal plants in Australia. So we've got ways of treating water, we've got ways of finding water and recycling it. We need an integrated approach that also matches how we use water, how we behave with water to reduce the energy. So thanks, and I look forward to chatting to you later on. Oh, it's much better with gin in it, but